What's up guys, I'm Caleb from Teen11777S. In this video, I'm just gonna introduce you to the how to do text coding in Vex. This is mainly a guide for newer teams. Obviously, building and stuff, but you also have to code so the controller knows what to do and the autos know what to do. So this is just for newer teams. Um, even in even in our region, in my region as well, it's pretty drastic with block code. Because overall, if you have text code, it's just gonna make life a lot better. Me personally, I don't use this program anymore. I use I use Pros with Lemlib for odometry, which is very nice. That's why this video is aimed for as a guide. So we're just gonna make a new code here. Oh yeah, make sure you have your competition template. Oopsie. Make sure you have your competition template. Awesome. My project one. I don't care. Okay, so we have our configs and such. So very important step. Add your controller. Add your chassis. And if you want to, if as you can see here, we're not going to use GPS for the sake of this video. No inertial sensor for this video. If you, as you can see, it's 4 motors. If you look at Little Will's video from Team 44252A, he'll introduce you, show you how to do a 6 motor drivetrain. It's super simple. We'll add a digital out, and we'll add a motor just for spinning. So the main basis of this video is, oh yeah, very important to turn this on because you need to mess with the configs a lot. So my main goal point of this video is just to introduce teams to basic functions like how to make a motor spin, doing simple stuff in autos. So obviously this is why I did that. Oh, whoopsie. Um, so Vex C you're really not going to touch unless you're going to want to add extra files, which I don't think it's necessary, but if you do, go ahead. I mean, that's where you would do it. Here's a very important part. So we have our, oh crap, I forgot the axes. See, this is when you do autocomplete, when you do expert robot config, expert autocomplete. Very important. Because this allows you to touch what's in the config to if you need to switch values or gear ratios. That's why it's very important to do it if you mess it up. So if, like I just did, like I said, I'm just doing this off the fly. Let's do 4 motor drivetrain, done, motor, blah blah blah, and digital out. Okay, cool. And set your axis on the, if you like split arcade or tank drive, I don't recommend tank drive. Obviously, this is a lot more. Every team does this, so make sure you have your third and fourth axis the up and down, and your first and second axis on the controller left and right. It's the most common, basic, and just flat out is amazing. It's proven to work. So now we have that. So as you can see here, if you see these true or false, now you can turn on your expert robot config because you really need to switch these stuff and these stuff in the configs. And if you need to, like I said, if you need to add anything, what you could do now is, as you can see, there's these false and true very booleans. Obviously, this is the way how your motors are gonna spin according to the pattern of your joysticks. So this is very important. Like I said, this is why we turn it on. If you need to switch these values to, like, I don't know, true. Obviously, you have to look at how the motors are direct are built, and if you see the little arrow that that it is. This is why we have um, expert robot config turned on. All right, so now we have our motor 5. This okay for drive, just for the chassis, you're gonna have to like mess with these values until you have one side is all true, one side's all false. Just for external motors that are not part of the chassis, you're completely fine. Just don't touch that. Obviously, if you go 6 to 1, oh, whoops, if you go 6_1, that means that's a blue motor. 18 and 1, that is a green motor. So as it reads off of it, like I said, if you need to change it, this is why we turn on expert robot config. So, like I said, this video is just a basic guide on a lot of teams that are beginners at Vex, and this is just going to make life a lot easier. Okay, so we have our config done, and well, you might be asking what the config H does. This is basically telling the brain what's inside the robot. And the config H is what we have to call out in the main. So if you want to change this name to controller, just controller, instead of controller 1, you could change it to controller. Just leave it as that. You're gonna have to do the exact same thing. I'll show when you see this M. Make sure it's saved. If you ever change the name, you're gonna have to do the exact same thing here. So because all files, the robot config main cpp, not really vex.h, but robot config.h, they all have to like see it's the exact same thing. So then you can call it up nicely. So we have that complete. Just very basic stuff. Like I said, if you want to add extra motors, because after you turn on extra robot config, you turn it off, and it deletes everything. So if you just want to add extra motor, copy paste this, that, put this to like whatever motor. We'll just say like the intake or something, because every Vex game has an intake. And then we would have to do this, and then we'll call this also the intake. So the file will see it's the exact same thing on this one and that one. So then the main won't freak out. And then, so now, as you can see, these are on separate ports. Obviously, you have to look at what your robot brain has and put every port. No, you do not have to do every specific port that the code just gives you. You could be super flexible with it. Like, let's say your left motor A chassis is a 19 or something. Your other one's in like what, 7. That's completely fine. Just make sure you line it up and make sure it's that motor in the exact port, and it should all be fine. Even with digital out, like the 3-wire ports on the side of the brains, very important if you know what those are. Obviously, this is why Vex is super complex with building, coding, and all that. Yeah, so yeah. So now we have our basic stuff. We have a chassis, kind of, and our axes are perfectly fine. See, remember, if you ever change the controller, 1, for this sake, we're just going to do that. Because all the files have to read. Like, see how I changed it there? This also freaked out as well. So then we also have to change this as well. There we go. Now it stopped. Okay, cool. Now we have this. So now we're going to do the most basic things. Let's say we want to make an intake spin. Alright? So you're going to say if, yeah, like I don't even use this, like I use pros now, so like a lot of this is also a lot of muscle memory. Dot button, alright, if control dot button, R2 dot pressing. Let's say the intake will have to dot spin, um, forward, if we look, let's just say 200 RPM. But you're gonna realize, well, I only have my intake spinning forward 200 RPM, and then that's why I have an else if controller 1 dot button R1 dot pressing. The intake will spin opposite way. Reverse 200 RPM. Okay. Alright, so once you download this onto your brain and you press R2, R1, you're gonna realize, yes, the directions work, but it doesn't stop when you don't release it off the button. So that's why we have, that's why we're gonna put an else, not an else if, because we're not calling it a controller. The intake dot stop. So now in your user control, and when you're just driving around, if you just hold R2, R1, but you release the button, it's gonna stop completely until you press the button. It's very, very basic. Okay, also in the main, this is it's very cliche, but you could do it in here in the while true. Um, or the user control. Obviously, they both work. It's just for stopping. This is where you're gonna want to do for trigger stop for taking your finger off the trigger. That's why I found the easiest. All right. So in pre-auto, this is what you would do if you did a PID function, which is very very complex, and I'm not really gonna. I mean, obviously study it, but this is where you would put it because pre-auton means like it runs throughout the entire. It runs forever. That's what PID is, but obviously we're not gonna do that. So just don't delete this, or else your main will stop working and all sorts. All right, now auto. So obviously, oh yes, we need to do the pistons. Man, I'm so stupid. All right, so now since as you know, if you're gonna use pneumatics, it runs off a true or false. Like if you press a button, this piston goes up. You press down, press another button, the piston goes the opposite. That's called a boolean. You need a boolean is true or false. So if controller one dot button a dot pressing digital out C, that is what we call it here in the config.cpp and config.h as our digital out, which will run our pneumatics, which is plugged to the C port of the brain. Dot C set true. All right, and then else if no, that voice crack is crazy. All right, else if controller one dot button b dot pressing digital out C dot set false. Okay, so as you could tell, there's a difference between motors and pneumatics. See, pistons run off of air. It just needs to know when to actuate and not when to actuate. The thing with motors is they rotate. This is just actuating because it doot 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 doot. That is all of pneumatics. It just runs off of booleans. You really don't need rotations because that's not how air works. Anyways, yeah. So this is you don't need an else right there because nothing's happening if you set it to false. No air is gonna proceed unless you have a leak. Alrighty. So now we're gonna go into auto. So now this is where things can get very complicated. Obviously, knowing what your chassis is, knowing how your chassis is built, that really depends on the speed that you're going at. So we're gonna say, alright, so we need to set a drive velocity and a turn velocity. If you set no drive velocity, no turn velocity, your robot is just gonna be insanely slow and run off the RPM that I think it has. I'm not too sure. Correct me if I'm wrong, but obviously, if you don't have a certain velocity for your drivetrain when you're going straight or turning, it's going to be very slow. So this is why we need to set our drive velocity to 50% of of the chassis power because we want it to be consistent unless because obviously I don't use this anymore. If you could like on pros it's slew, so because it's with odometry with PID for a drivetrain. So yeah, dot set turn velocity. We can also do that as 50%. Obviously, you don't have to have it as 50%. Whatever works for you. All right, and now we have that. Okay, so now you're gonna have to. Well, you're gonna ask me like, how do I make it go forward for this amount? So now we have to do drivetrain dot drive for or turn for. Drive for 12 inches. Okay, if you're gonna say it's 12 inches, it's just gonna go forward 12 inches. But if you put reverse, it'll go reverse 12 inches, vice versa. And drivetrain dot turn for 90 degrees. So when you do this stuff, it's not gonna be exactly 90 because you're not gonna have inertial sensor or a PID loop with the inertial sensor. So it's just gonna run off the encoders that the motor has, which is not as super accurate, but it'll be kind of close. if it's a rough, it's gonna give a rough estimate of 90, which still works, but not as insanely efficient. So now we'll just set our uh, velocities aside. Oh man, I can't type today. So after we have that, we have our basic. Just obviously you can go 24 or 36, and yeah. So now we have that, and then you would do the exact same thing if you obviously you could now without the button presses you could just put this intake here and copy paste it and it'll spin once it's completed because it'll read line by line by line by line by line. Once it does that, it's just going to spin till auto ends because you're not telling it to do it unless you put a wait. Vex. Back. So now you're going to have to make it, what you're going to do now if you want the intake to stop spinning, you're going to have to do well, you could just, well, because it's a motor, it's just going to, you can't just tell it, it's just going to run it for like, I'd say like 0.1 seconds, then stop if you just did this. Like intake dot stop. Like it's not even because code just reads it line by line. It's not gonna continuously because it's gonna read all four 200 RPM and just stop. So you need to have it as a wait if 2 seconds or whatever. If you're trying to make it stop, like let's say you're intaking the object but you don't need it to spin anymore. This is why we have the wait there. Wait 2 seconds, then you can say intake dot stop. And same thing with this. For pneumatics, you just copy paste this. Say true, and then let's say drivetrain dot drive for like 30 inches. Like I said, I'm just getting rusted, and then you can say like false. So that is practically it. This is like the most basic raw I could give you. Hope you enjoyed the video. Like I said, this is just a guide for teams that are new to Vex and coding, and teams especially new teams, especially in my region, because it's pretty drastic. So thank you all for watching.